Just to throw it out to you folks to think about. But we would consider this to be a low phosphorus risk soil. And why would we do that? Because we got green coating. Look at this stuff. This soil is well coated. We got about 95 or 96% quartz sand. But on that quartz sand, what do we got? We got about half silt and half clay. You guys say, well, how do I know that? Well, I'm making it up. But I've seen a lot of data. The quartz, the silt, say we have 4% silt plus clay. The silt is 2%. That's all quartz. 2% clay. Half the clay is quartz. So we got 1%, and probably about 3/4 of that are weather resistant phyllosilicates like kaolinite and hydroxylaminated vermiculite, and resistant other minerals like gibbsite. And only a small fraction of it are metal and would be metal and metal oxides like goethite and hematite and things like that. But yet, those metal oxides have almost completely relate to the phosphorus absorption capacity of the soil, particularly the non-crystalline forms of it. The oxalate extractable aluminum and iron, if you did a correlation between oxalate extractable aluminum and iron from this soil and some indicator of phosphorus absorption, like for those of you that are soil chemists, the Langmuir absorption max, or just some kind of a rough indicator like a single point absorption experiment, you would find that they would correlate extremely highly, sometimes 0.85 to 0.9 R square with that phosphorus absorption indicator, with metals, phosphorus absorption indicator versus metals. So that little bit of metal oxide plays a major role in anion absorption and environmental issues in Florida, environmental concerns about contaminants that involve anions. Based on what Dean Rue and some other folks, including me to some extent, have done, is it might take 40 pore volumes to get a breakthrough of phosphorus through this E horizon. At a constant, now you have to define the concentration. 40 pore volumes of what would be typically a concentration of flush dairy manure, like a dairy spray field, which would be about 40 parts per million total phosphorus and about 20 of soluble phosphorus. So we're talking about, say, 20 parts per million of soluble phosphorus. It could take 40 pore volumes, and that would be a long time in terms of rainfall to get phosphorus through this right here. To get it through down there would take a lot longer than that, because we have a lot more metal oxide and clay, other clay components that can absorb phosphorus down there. The only concern I have about that argillic layer is whether in the natural flow of water through the system, you're getting complete contact. I mean, if it's not piston flow, that is, if water's not just going straight through and making really intimate contact with that argillic, then we could be overestimating its ability to retain phosphorus, retard its movement, and keep it from getting to, say, springs, getting into the limestone itself. And arsenic the same. And one thing it could do is it could bypass. It could flow preferentially along the top of the E horizon and find its way into a sinkhole, or it could flow preferentially through the soil matrix itself, going primarily through macropores and not having a long contact with the soil matrix itself. A third thing that could happen is that it could flow preferentially through the depleted zones. That is, the zones that have less clay and less iron and aluminum. And it could follow a network of paths that way, and by virtue of being preferentially flowing through the least retentive part of the argillic, then we're not getting anywhere close to the retardation that we would get if we took the argillic and blended it all together and did absorption determinations on that. So the soil architecture, in addition to soil components, that is the soil structure and the arrangement of components, cutans if you'd like, the arrangement of depleted zones and concentrations. The other thing is that those concentrations would hold an incredible amount of phosphorus. But you have to have contact. If most of the concentrations are in the interior of PEDs and most of the depletions around the exterior, and we have a network of those depletions around the natural aggregation, and the concentrations are occluded, then you could bypass most of that absorption capacity. I have said a lot of stuff in the last 5 or 10 minutes. Do you have any questions about any of the things that I've talked about? I wish I had recorded that last 10 minutes, because I don't think I've ever said that much.
I just did.
Okay. Oh no. Oh no, I didn't mean that. Yeah. But you guys, am I making any sense? You guys understand what I'm saying?
Yeah, yeah.
Okay. Well, then we're pretty much done. So we're ready to head back to the barn. I hope you guys enjoyed the tour.